simple question related to this. Okay, an object is thrown up with a velocity u. Okay, the maximum height reached is h1. If it is thrown up with a velocity 2u, what will be the maximum height reached h2? Question, write the question. Same, based on same concept. Okay, an object is thrown up. An object is thrown up with a velocity u. With a velocity u. Full stop. The maximum height reached by the object is h1. The maximum height reached by the object is h1. Full stop. The same object is thrown up with double its velocity in bracket 2u. Is thrown up with double its initial velocity 2u. Okay.
Hello, sir. Good morning.
Good morning, sir.
Sir, good afternoon.
Good afternoon, sir. Sir, is it
Hear you,
audible,
sir.
sir?
You can continue.
Yes, yes, sir. Yes, yes.
Yeah, voice is clear.
Yes, yes, yes. Okay. The object is thrown up with double the initial velocity, that is 2u. The maximum height reached is h2. Find the ratio. Okay, you can find either you can find h2 or find the ratio h1 by h2. How to find? Very simple. How? You know that h is equal to u square by 2g. So h1 is u square by 2g. h2 is 2u whole square by 2g. What is new velocity? 2u. So 2u whole square by 2g. What is 2u whole square? 4u square by 2g. What is u square by 2g? What is u square by 2g? h1. h2 is equal to 4h1, or h2 by h1 is equal to 4 by 1, or h1 by h2 is equal to 1 by 4. Easy. Understood this equation? U square by 2g? Yes or no? Yes. In projectile motion, you have maximum height reached h max is equal to u square sin square theta by 2g. So no. Projectile motion, the equation for maximum height is u square sin square theta by 2g. Here it is u square by 2g. Getting it? Why u square sin square theta there? U sin theta is vertical component of velocity. So u square of that is u square sin square theta. Okay, all things are related. When you analyze that, everything is related. Okay, fine. Understood? Sure. Similar question. Wait, no, similar question. An object is thrown up with a velocity u. An object is thrown up with a velocity u. Its time of flight is t1. Its time of flight is t1. Another object of mass 2m. The first case, an object of mass m, you write. Okay. An object of mass m, initial case. An object of mass m is thrown up with a velocity u. Its time of flight is t1. Another object of mass 2m is thrown up with a velocity 2u. an object of mass m, another object of mass 2m is thrown up with velocity 2u. Its time of flight is t2. Its time of flight is t2. The ratio of t1 by t2 is a 1 is to 1, b 1 is to 2, c 2 is to 1, d none of this. Options are also given. First, they are asking you to find the ratio of time of flight. Equations for time of flight you need to write. Time of flight is equal to yes 2u by time of flight is 2u by okay. First case t1 is equal to 2u by g. Initial velocity is u. Accelerated cavity is g. In second case t2, initial velocity is 2 into initial velocity is 2u. Yes or no? So 2 into 2u, right? G is that is equal to 2u by g is 2. 2u by g is t1. 2 times t1. So t1 by t2 is equal to 1 by 2. 1 to 2. Clear? Easy? Sure? Yes. You see? Good? Now that time of flight is equal to u by g. Correct. An object of mass m is thrown up with a velocity u. Okay. Reaches height h. Maximum height is h. That means its final velocity is 0. Okay. You know that v square is equal to u square minus 2gh. V square is 0. So it is u square is equal to 2gh, or h is equal to u square by 2g. Okay, and t is equal to u by g. That you know already. Now or what is if it is thrown up with the velocity u? Okay, what is the displacement traveled in time of flight ta? H is equal to displacement traveled is equal to ut minus half g t square. U into what is t? Time of ascent. U time of u by g minus half into g into time of ascent is u by g. T square is u square by g square. T square. T is u by g. So t square is u square by g square. Get u square by g minus half u square by g, that is u square by 2g, which is equal to u square by 2g. Same thing. In this way also you are getting same thing. Okay, fine. Now last class we have discussed if an object is dropped from a height h, the ratio of the displacement traveled in by it in t, 2t, 3t will be, last class we have discussed, an object is dropped from a height h, the ratio of distance traveled by it in a time t, 2t, 3t, etc. will be in the ratio of displacement traveled will be in the ratio. Ruchi, 1 is to 1 is to 1 is to 1 is to, yes, you last class we have discussed. Yeah, 1 is to 2 is to 3. Adi yavadu? What's the heading for that? There are many ratios like that. 1 is to 3 is to 5, 1 is to 4 is to 9. Root 1 is to root 2 minus root 1 is to root 3 minus root 2. There are many ratios like that. But in this case, what is the exact ratio? What's the question? The object is dropped from a height h. The displacement traveled by the object in a time t, 2t, 3t. Be in the ratio 1 is to 1 is to 1 is to 4 is to 9. Yes or no? Not written? Yes? You have written? Very lila. Okay.
I have written.
You have written, but you don't know where it is. How to find that? How did you find this? How did you find it? Dropped. S is equal to ut plus half at square. It is dropped, so ut value is 0. Okay. S is equal to half gt square. Okay. So S is proportional to t square. So displacement traveled S1 is to S2 is to S3 is equal to t square is to 2t square is to 3t square. That is equal to 1 is to 4 is to 9. Write down. If it is not written, write down. Completed. ಅರ್ಥ ಆಯ್ತಮ್ಮ? ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ? ಅರ್ಥ ಆಯ್ತಾ ಇಲ್ವಾ? See, we are dropping an object from a height h. From here, we are dropping an object. What is its initial velocity? U is equal to 0. What is the acceleration? G. Suppose displacement traveled is h. Equation yavadu? You know that h is equal to ut plus half gt square when it is going down. Okay. So u is 0. Initial velocity is 0 because it's just dropped. So h is equal to half the t square. So when time is t, what is displacement? H is equal to half gt square. When time is 2t, what is the displacement? H2 is equal to half g into 2t square. That is 4 into half gt square. Is equal to 4h. Yes. When time is equal to 3t, displacement is half g into 3t square. That is 9 into half gt square. That is 9h. Ratio h1 is to h2 is to h3 is 1 is to 4 is to 9. ಗೊತ್ತಾಯ್ತಾ? Oh, fine. Understood? Yes or no? Same case. An object is dropped from a height h. Okay. So what is the displacement traveled in time t? Displacement in time t? Displacement in time t. H is equal to ut plus half gt square. Ut is 0. H is equal to half g t square. Yes. Or from this, t is equal to 2h by g. Time taken to travel a displacement h is t is equal to 2h by root of 2h by g, or t square is equal to 2h by g, or t is equal to root of 2h by g. So yes or no? Got it? Understood? What's the situation here? An object is dropped from a height h. Yes, dropped. That means initial velocity is 0. The displacement traveled by the object in time t is h is equal to half gt square. S is equal to ut plus half at square. U is 0. Acceleration is g. So h is equal to half g t square. Okay. Or if you rearrange this, you will get 2h by g is equal to t square, or t is equal to root of 2h by g. Yes. What is this t? T is the displacement traveled, time taken to travel the displacement h. So you can know that time is proportional to root h. Time is proportional to root h. Yes. Yes. Okay. Now, did you write this? Did you write this? Yes or no? Yes. Okay. Now, write down next line. An object is dropped from a certain height h. Object is dropped from a certain height h. Full stop. The time taken by the object, the time taken by the object, the time taken by the object to travel to travel a successive distance of 1 meter each, successive distance of 1 meter each is read the question, read the situation. What is asked? Object is dropped from certain height h. What is asked? The ratio of time taken by the object to travel a successive distance of 1 meter each. That means dropped from height h. First 1 meter time taken is t1. Next 1 meter time taken is t2. Next 1 meter time taken is t3. What are you asked? You are asked to find t1 is to t2 is to t3. Yes, sir. Draw the diagram and mark what is asked. So it will be easy for you to understand. Yes? Fine. How to find? How to find? Already you know. T1. Time to travel. First 1 meter. How to find out? S, you know that S is equal to ut plus half at square. In this case, u is 0, ut is 0. So distance h is equal to half at square. Yes or no? Yes. We are given h is 1 meter. So you need to find t. So t1 square is equal to 2 by g, or t1 is equal to root of 2 by g. 2 into 1 meter. H is 1 meter. Yes. Should I explain that again? Should I explain that again? You need to find the time for first 1 meter. Initial velocity u is 0. Acceleration is g. Distance traveled is h, that is 1 meter. Substitute. S is equal to ut plus half at square. In this case, h is equal to half a t square or half gt square, or t square is equal to, in this case it is t1 square is equal to 2 into h by g, or in this case h is 1, so t1 is root of 2 into 1 by g. Yes or no? Yes or no? So time t1 is formed. Now I need to find time t2. How to find time t2? Let it be point A, point C, B, point C, point D, etc. Time t2 is the time taken to travel from B to C. So no, time taken by the object to travel from B to C. How to find the time taken by the object to travel from B to C? Time taken by the object to travel from A to C minus time taken by the object to travel from A to B is time taken by the object to travel from B to C. Yes or no? Yes or no? What is the time taken by the object to travel from A to C? How to find that? Initial velocity for that case is 0. Distance traveled is 2 meter. Acceleration is g. So by substituting in this case, in this formula or in this formula, time taken by the object to travel from A to C is square root of 2 into, what is the distance from A to C? Distance from A to C? 1 meter plus 1 meter, total 2 meter. 2 into 2 by G. Yes or no? Yes or no? What is the time taken to travel from A to B? Is root of 2 into 1 by G. Now you tell me what is understood. Yes? Now tell me what is time taken to travel from B to C, that is T2 is equal to root of 2 into 2 by G minus root of 2 into 1 by G is 2 is equal to root of 2 by G into root 2 minus root 2. No. Yes? Understood? Yes or no? Understood? Okay. Now that is T2. Now similarly, how to find T3? T3 is time taken by the object to travel from A to D minus time taken by the object to travel from A to C. Yes? What is the time taken by the object to travel from A to D? Root of 2 into distance 1, 2, 3. 2 into 3 by G minus what's the time taken to travel from A to C? 2 into 2 by G. That is equal to root of 2 by G into root 3 minus root 2. Yes? Yes? So what is the ratio? T1 is to T2 is to T3 is root 1 is to root 2 minus root 1 is to root 3 minus root 2 is to etc. 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 Go through it once. Go through it once. What's the question? The ratio of time taken by the object to travel a successive distance of 1 meter when it is dropped from a height h. Yes or no? Yes. What's the question? What did you write? An object is dropped from a certain height h. The time taken by the object to travel a successive distance of 1 meter each. Same thing. Correct. Understood the situation? An object is dropped from a height h, that means from the point A. First 1 meter, it takes t1 time. Second 1 meter, it takes t2. For third 1 meter, it takes t3. You're asked to find t1 is to t2 is to t3. Understood how to find out? It is root 1 is to root 2 minus root 1 is to root 3 minus root 2 is to, etc. Next one will be root 4 minus root 3. Next will be root 5 minus root 4. Next will be root 6 minus root 5. Next will be root 7 minus root 6. Goes like that. Ratio is like that. Here? Yes. Yeah. Fine. Now let's move to your topic. Relative motion. Relative motion. What do you mean by relative motion? This motion of an object with respect to another. Relative motion means motion of an object with respect to another. We are finding or we are referring motion of an object with respect to another object, which may be at rest or which may be in motion. I don't know about that. Which can be at rest or which may be moving. Maybe in the same direction or maybe in the opposite. I don't know. Okay, fine. Then what do you mean by relative velocity? In this, we are referring velocity of an object with respect to velocity of another object. We are, suppose two objects are moving. Okay, I'm finding the velocity of the second object with respect to velocity of the first object. Relative velocity. Relative acceleration means velocity of, acceleration of an object with respect to acceleration of the other object. Clear? So it is relative. I may have another point of reference. Maybe it may be having velocity or acceleration. Or if I want to find the velocity of an object with respect to other, so here that means velocity of this object is related or understood by knowing or by considering the reference that the velocity of the other object. Clear? For example, okay, an object A is moving with a velocity VA. Okay. Another object B is moving with velocity VB. Okay. Now, relative velocity of B with respect to A. I'm finding the velocity of B with respect to A. That means relative velocity of B. Means velocity of B with respect to A is VB minus VA. Velocity of B minus velocity of A. Velocity of B minus velocity of A. You imagine velocity of B is greater than velocity of A. Velocity of B is greater than velocity of A. What will be the value of VB minus VA? VB minus VA will be VB minus VA will be positive. Sorry. Velocity of B is greater than velocity of A. For example, velocity of B is 10, velocity of A is 5. What is VB minus VA? 5. Positive. Correct? In that case, the relative velocity will be positive. Suppose velocity of A is greater than velocity of B. Velocity of A is greater than velocity of B. What will be VB minus VA? What will be VB minus VA? Negative. That means when VB minus VA, if it is positive, that means the object B is moving away from the reference point. If VB minus VA, if it is positive, that means B is moving away from A. Moving away, either along positive x-axis or negative x-axis. I don't have to worry about that. If VB minus VA is negative, that means relative velocity of V with respect to A is negative. That means V is approaching towards A or A is approaching towards B. Even if they are moving along the same direction, B is approaching towards A. Are you getting the point? Sorry. Clear? ಗೊತ್ತಾಯ್ತಾ ಇಲ್ಲ ಗೊತ್ತಾಯ್ತಾ? For example, Ganesh is moving in a bicycle. Okay, there is a Ganesh moving in a bicycle with a velocity of 2 meters per second. Okay, let it be VA along this direction. There is a car moving in the same direction with velocity VB, velocity of 5 meters per second in the same direction. I need to find the relative velocity of Ganesh with respect to the car. What is relative velocity of Ganesh with respect to car? Is VA minus VB. Correct? AB. VA minus VB. 2 minus 5 is minus 3. Correct. Relative velocity is 3 in magnitude. Direction is negative. What's the meaning of that? This person, this object A, is ultimately approaching towards the reference point B. Yes or no? Because car is having more speed than this, so it approaches. Clear? That's meaning of it. Suppose, for example, the car is having a speed of 5 meters per second. The object or Ganesh is having a speed of 10 meters per second. What will be VA minus VB? 10 minus 5, that is equal to plus 5, positive. 10 minus 5 is 5. That means this object A is moving away from this reference point. So if relative velocity is negative, that means the object is approaching. Relative velocity is positive, that means it is moving away. Ultimately, we can say, based on situation, we'll come to know it clearly. Yes? Understood? Okay. Now, very simple case. If first case, two objects are approaching each other. Two objects are approaching each other. That means object A is moving in this direction with A, and object B is moving in this direction with VB. The relative velocity in this case will be relative velocity of A with respect to B is VA minus VB. VA direction is along positive x-axis, that is positive. What is velocity of B? It is along negative x-axis, that is minus, negative. Okay, so VA minus VB is VA minus VB, that is VA plus VB. Are you getting it? Are you getting it? Yes. For example, VA is 5 meters per second and VB is 10 meters per second. The relative velocity is relative velocity of A, or velocity of A with respect to B is 5 plus 10, that is 15 meters per second. They are moving, approaching each other. The relative velocity is sum of the magnitude of velocity of each object. 15 meters per second. Clear? Okay. Suppose if they are moving in opposite direction, same case, moving in opposite direction. Okay. A is moving in this direction and B is moving in this direction. Okay. You need to find velocity of A with respect to B. Relative velocity of A or velocity of A with respect to B. You tell me, what is the sign of VA? Negative. What is the sign of VB? Positive. So VA minus VB is VA minus VB. VA is minus VA minus VB. is minus of VA plus V. Yes or no? Understood? Yes. Now tell me, what is, will you copy this? Yes. Tell me, what is V, velocity of V with respect to A? Yes. VB minus V. VB is positive. VB minus V is VB plus VA. That is positive. Yes. Clear? So VAB is minus of VBA. That's all. VAB is minus of VBA. Better. Yeah, in this case, we have seen two objects either approaching towards each other or moving away from each other. Now, let's see. Two objects are moving in the same direction. Two objects are moving in the same direction. Object A is moving in a direction VA with velocity VA, and object B is moving in this direction, velocity VB. Okay, tell me, what is velocity of B with respect to A, or relative velocity of B? VB minus VA. V minus VA. VBA is positive if VB is greater than VA. Relative velocity of B with respect to A is velocity of B with respect to A is positive if velocity of B is greater than VA. Okay. Velocity of B with respect to A is negative if VB is less than VA. Okay. Some cases related to relative velocity. A person is used to stand on an escalator and to reach from the ground floor to first floor. That means the distance traveled is x. He used to take time t1. He used to take time t1. What is this case? A person used to stand on the escalator and the escalator moves up. Okay, so velocity of the person will be velocity of escalator. Yes or no? He is standing on the escalator and escalator moves up. The velocity v suffix e, and he used to take t1 time to reach the top. Some other day or some other case where the escalator was not working. It means this person used to, he walks up. What will be his velocity? Velocity of the man. He used to walk up, and the distance traveled in this case is same x, because same escalator. Distance traveled is same, and he takes time t2 to reach the top. First case, he used to stand on the escalator and escalator moves up with the velocity ve. He takes t1 time to reach the top, and if the escalator is not working, he used to walk up with the velocity v suffix n, and he takes time t2. Now my question is, if he walks on a moving escalator, time taken is t, then what is time taken t? If he is walking up on a moving escalator, in this case what happens? Escalator is moving, upon that he is walking up. Yes, if the time taken is t, what is that time taken t? Options, tumba options kodtare. T1 T2 by T1 minus T2, T1, T2 by T1 plus T2, T1 plus T2, none of these. Understood the situation? Understood the situation? Okay, we can solve this by using the concept of relative velocity. Okay, tell me or consider the first case. What is the distance it has to travel? X. Time taken is T1. So can I write X by T1 is VE? Distance by time is velocity. Or can I write X by VE is T1? Distance by velocity is. In this case, what is distance it has traveled? X. Time taken is T2. Velocity is velocity of mass. X by T2 is Vm. Or X by Vm is T2. Yes or no? You tell me, if he is walking up on a moving escalator, what is his velocity V dash? He is walking up on a moving escalator. His velocity will be velocity of escalator plus velocity of the person. Yes or no? Yes or no? Yes or no? Yes or no? Escalator is moving up with velocity VE. He is also walking up, so his velocity will be VA plus VB, same direction. Okay, so it is taking along with him. So VA plus VB, or V dash will be VE plus VM. Time taken is T. What is the distance it has to travel? X. Okay. Can write T is equal to X by V dash. That is X by VE plus VM. T is equal to X by V plus VM. Vm is X by T2. VE is X by T1. I can write it is X by T1 plus X by T2. That is X by X into 1 by T1 plus 1 by T2. Yes. Yes. It's not visible. So that is equal to X by X common 1 by T1 plus 1 by T2. This is cancelled. That is 1 T2 by 1 plus T2. Taken is T1 T2 by T1 plus T2. Yes. Clear. Ruchi. Some simple situation. Will you be able to answer? Okay. Write down. A train is moving with a speed of 2 meters per second on a straight track. On a straight track. A man on the same train is walking inside the train with a speed of 2 meter per second in a direction opposite to the direction of motion of the train. Opposite to the direction of motion of the train. Full stop. A person standing next to the track, will observe the velocity of person standing next to the track will observe the velocity of the man as option A, 2 meter per second, option B, 4 meter per second, option C, 0 meter per second, option D, data is insufficient. Data is insufficient. Read the question or read the situation. What exactly is given, and you imagine that you are on the same spot and observing that. Answer. Okay, listen. What's the velocity of the train? 2 meter per second. That is with respect to ground. Correct? Yes or no? What is a velocity of the man? 2 meter per second in the opposite direction with respect to the train. Yes or no? Velocity of man with respect to train is 2 meter per second. Since it is opposite direction, I can write minus 2 meter per second. Velocity of train with respect to ground is plus 2 meter per second. Sorry. What are you asked to find out? Velocity of man with respect to ground. Velocity of man with respect to ground. Velocity of man with respect to train is velocity of man with respect to ground minus velocity of train with respect to ground. Okay. Velocity of man with respect to train is velocity of man with respect to ground minus velocity of train with respect to ground. What is velocity of man with respect to train? Minus 2. What you need to find out? Velocity of man with respect to ground. Minus 2. Velocity of train with respect to ground is plus 2. Velocity of man with respect to ground is minus 2 plus 2, that is 0. Yes, understood. Understood. This is by steps. Or else easily I can find out. Imagine that train is moving in this direction with 2 meters per second. Train is moving in one direction with 2 meters per second. The person inside the man is walking in the opposite direction with 2 meters per second. What is his relative velocity with respect to ground? Be 0. It's like treadmill when we walk, no? Yes or no? You are walking forward with some velocity, and the floor or the belt is moving backward with the same velocity. Ultimately, when we look from ground, we will be at rest. This is the same situation. Yes or no? The platform is moving in one direction with some velocity, and the person is moving in the opposite direction with the same velocity v, such that when we look from ground, the person will be steady. Getting it? It's like walk in gym. When we go to gym, the treadmill, we walk. Okay, in that screen we can see our velocity. But actually, are we moving with respect to ground? We are still. Yes or no? Will be at the same position. Same case. In that case, the belt is moving backward with some velocity. We are on the belt moving forward with same velocity v. Ultimately, with respect to ground, we will be at rest. Yes. Same way, a person is swimming upstream. Upstream means against the flow of water. Okay. Velocity of water is 2 meters per second, and velocity of the person is with 2 meters per second. Ultimately, the velocity of the person with respect to ground will be 0 because water is going back with 2 meters per second. That means the water is taking the person along with it with 2 meters per second. But the person is swimming and his speed is 2 meters per second up. So that ultimately the person will not move from his place with respect to ground. Got it? Yes or no? Just revise the topic relative velocity. It's almost time. I don't have time to go for the next case or next topic. So just revise the 1 or 2 problems or situation we have discussed today. Okay. Fine. Do that. And if you have any doubt, you can ask me. Those who are online, let me check. Online. Okay, only one person. Okay. So we'll solve more problems of relative velocity. We'll discuss more situations, more concepts in the next class. That means tomorrow.